So today we'll get started. Consider this training as a combination of fundamentals plus administration training for Google Cloud. Now, what happens when it comes to Google Cloud? We have multiple certifications. So, in fact, after we complete this training session, you will also be prepared for those certifications. All you need to do is just go through the certification curriculum, and accordingly, you need to prepare for any specific service that we did not include in this training session, or we did not include at a level which it should have been, which is needed for the certification. So that's what we are going to do. So I will be using this Word document. I call it session transcript. And the benefit of this Word document is that it will have reference of topics and services or any discussion that we have during the training. The first certification is fundamental certification. In this certification, we primarily follow, I'm saying the certification name, the official name of the certification is GCP Cloud Digital Leader. So we call it Cloud Digital Leader. And you call this certification as level 100 certification. So this is level 100. When I say level 100, I basically means that this is the starting point. Level 100 basically means basic. Level 200 is intermediate. Level 300 is equivalent to an architect, or you can say an expert level certification. But as I informed yesterday, nobody is an expert. Nobody is a subject matter expert here when it comes to cloud. We all are practitioners. So Google Cloud Digital Leader, which is the fundamental certification of Google Cloud. And what does this certification cover? This certification basically covers introduction to Google Cloud, wherein it basically introduces what Google Cloud platform is all about, how is Google managing the cloud data centers, how is Google offering services from its cloud data centers to end users, how is Google managing multi-tenant architecture of services, how Google is offering services from their data center, how Google is ensuring the secrecy, security, and confidentiality of data which belongs to the customer, or when customers are storing or hosting their workload and applications in Google data centers or in Google region, how Google is securing the assets. That's what this certification talks about. So introduction to Google Cloud, and then it also deals with GCP global infrastructure. When I say global infrastructure, it basically means how big Google Cloud platform is, what all countries and regions it has its presence in, how Google is building the data centers, how it is arranging those data centers to provide high availability, fault tolerance, operational efficiency for various workloads and applications that you can deploy in Google Cloud. That's what global infrastructure is all about. Then you also cover various services offered by Google Cloud across categories. So when I say categories, there are categories like IM, compute, network, storage, AI ML, big data, security, etc. These are categories of services. When we log into Google Cloud Console, you will see that services are arranged into categories. So you click on a category and you see multiple services inside that category. This is the arrangement method. So this certification also deals with various services. For example, what all compute services are available in Google Cloud. For example, we have compute engine, we have Kubernetes engine, we have Cloud Run, we have App Engine, we have Cloud Functions. Similarly, what all storage services are available in Google Cloud, wherein we have Cloud Storage Bucket, Firestore, Cloud SQL, BigQuery. That's what it talks about. So it basically deals with fundamental introduction of those services or use cases, that which service or which use case can be addressed with a set of services. That's what Cloud Digital Leader certification is all about. It's a pure play theoretical certification. There is absolutely no hands-on lab or no practical is involved in this certification. The certification comprises of MCQ, and they are pure play MCQ based on scenarios and based on services knowledge of Google Cloud. That's what fundamental is all about. Then comes next level, which you can say administration. Administration certification. When I say administration certification, the certification is GCP Associate Cloud Engineer. In short, we call it ACE also. This is the associate level of certification, and you can call it level 200 certification. So when I say level 200, it basically means with this certification, you will have all of this knowledge plus the provisioning and administration knowledge. So you will know how do we create identities or principals in Google Cloud? How do we assign them policies? How do we create virtual machines in Google Cloud? What are various configuration options that are available while you provision a virtual machine? Similarly, when you provision a VPC, what all options are available? Different types of VPCs, how do you provision it? How do you configure firewall rules? How do you configure routing? How do you create subnets across zone? All that comes into administration certification, which is GCP Associate Cloud Engineer. Now, it does not include all the services of Google Cloud. It includes core services of Google Cloud. When I say core services, it includes compute, network, IAM, storage. It does include logging, monitoring, and auditing. It also includes some aspects of security in Google Cloud. That's what administration certification is all about. So it basically includes end-to-end management. Management includes provisioning, implementation, configuration changes, optimization. So end-to-end management of GCP core services. That's the first thing. Second, it includes basics of security and configuration. And it also includes CLI. CLI is basically command line interface. So in Google, there are multiple ways of managing the Google resources. And so if you want to provision a Google service, please disregard background noise. There is a marriage function in the neighborhood. So I can't help it. So when it comes to command line interface, are you able to hear the sound in the backend first of all?
Not much.
Not
No.
much. If you feel that it is really disturbing, we'll think of something else. As long as it is not disturbing, let's continue. So command line interface. So there are multiple ways to manage the services in Google Cloud Platform. A is console. We can use the console, which is something that I shown yesterday. Now, the benefit of console is that console is graphical user interface, which basically means you will have buttons, you will have navigation panel, you will have options to exercise and manage the services. The other method is command line interface. It's like a black screen, DOS screen, disk operating system. You deploy Google Cloud CLI, which is GS Util or Google Cloud Shell. And inside the shell, you write commands. And using the commands, you interact with Google backend and you give instructions to execute an action. So if you want to provision a compute engine instance, you can also write a command and then execute it that will send an instruction to perform some action in the backend. So that's the another options. This certification also includes the CLI part, which is GS Util or Google Cloud Shell concepts, other than managing the resources from the console. So this is what Associate Cloud Engineer is all about. Then comes the next level of certification, which you can call. Now, in this certification, you get the provisioning knowledge. So you get some consulting knowledge in terms of what all services are available, how do you provision that service, and what use case that service satisfies or addresses. That's what you get in this certification. Then comes the next certification, which is architect certification. Architect certification. And architect certification is professional cloud architect GCP Professional Cloud Architect. In short, we call it PCA also. And this is level 300. Level 300. Now, what happens in this certification? In this certification, you take a step ahead. Now that you have good understanding of service provisioning, core services provisioning, you will take a step ahead wherein you will understand, you will dig deep into those services and you will understand the design and architecture aspect of it. So you basically understand the design and architecture aspects of design and architecture aspects of Google services. That's what you do here. So in this certification, you are expected to know how do we design a VPC, network infrastructure in Google Cloud, based on certain requirements. So design and architecture aspects, this includes landing zone design. So when I say design and architecture, you basically design landing zone. Google also provides you a well-architected framework, which is a set of founding principles or set of pillars, fundamental pillars that will help you to design and architect the services in Google Cloud. So that's what it talks about, well-architected framework. It also talks about Google Cloud Adoption Framework. So that's what this certification is all about. And so this is more into design and architecture, landing zone, well-architected framework, cloud adoption framework, typically something that an architect does. That's what this certification is all about. So these are the three main certifications in Google Cloud. Now, other than these three certifications, we also have role specialty certifications. And these specialty certifications are also level 300 certifications, but they basically relate to a specific specialty. When I say specific specialty, let's say you are into networking. uh, you have been working into networking domain, or you've spent majority of your time working with networking services. So you have good knowledge of configuring switches and routers. You have good knowledge of routing protocols like IGRP, BGP. You have good knowledge of configuring MPLS VPN connections, IPsec VPN tunnels. You have good knowledge of network monitoring, network security, configuring firewalls, configuring configuring web application firewalls or network firewalls or next gen firewalls, then you basically go for specialty certification. So Google has a dedicated page which contains all of this certification information. So let's navigate to that page. So this is the page, Google Cloud certifications, and here you see certifications. So you can see the certifications are divided into three categories: foundation, associate, and professional. Foundation is fundamentals, associate is administration, and professional is architect level certification. Now, under professional, you have multiple certifications. So cloud digital leader, I talked about; cloud engineer, I talked about; cloud architect, I talked about. Then comes specialty certifications depending on your roles, depending on your stream or your professional background. So if you're into databases, you can think of doing cloud database engineer certification. If you are a developer, you like writing lines of codes, you're a programmer, you can go for developer certification. If you're into big data, Hadoop, data lake, you can go for data engineer certification. You're into DevOps, you can go for DevOps certification. If you're more into security, now when I say security, it includes both infrastructure, application, network, governance, risk, and compliance. So it's a composite or comprehensive security certification. Then network engineer, this is primarily focusing on networking services of Google Cloud. How do we configure various networking services? Google Workspace is a different service altogether. It has a different console also, which is admin.google.com. And from here, you can actually manage identities and Google Apps services. So Google, similar to Microsoft Office, you have Google Apps. Microsoft Office has Microsoft Word, PowerPoint, Excel. Google has Google Sheets, Google Docs, Google Slides. Similarly, Google has Gmail. Microsoft has Outlook. So Google has comparative services, which is collectively known as Google App. And if you want to manage Google App, or if you want to manage identities for Google Cloud, this is the certification, which is Google Workspace Admin. And then you have another certification, which is machine learning engineer. If you're more interested in Google Cloud machine learning services, which is Vortex AI, or other machine learning services that Google primarily promotes or Google is currently focusing on, this is the certification that you can target. So these are the certifications in Google Cloud. Now, what are we focusing on in this training? We are not focusing on any of these certification. What we are currently focusing on is the project that you are going to support going forward. So very soon you will have a couple of existing customers providing additional responsibilities over and above what you are already managing for other clouds. And you will also be supporting Google Cloud. So you will be supporting some specific services to begin with. And this is where this training will be focused on, based on the mandate or based on the support scope or scope of work document that I've received from your management. So I put together the list of services that I will be covering in this training. Now, by the time we are done with this training, you will be ready for first two certifications for sure, because we will cover the basics, which is fundamentals, and we will cover the administration, which is the cloud engineer part. So after this training is over, you can sit for any of these certifications. Now, in order to clear the certification, your preparation has to be very, strategic, because you need to focus on the certification curriculum, the syllabus, and you need to go through the dumps. Dumps contain 70 to 80% of the questions that are asked in the certifications. Whenever you feel that you're ready for these certifications, just drop me a note. I will share the most recent dumps with you, and take my words, 70 to 80% of the questions that you will see in the certification will come from the dump. And the passing marks is 70. So you will be able to clear the certification in the very first attempt. However, certification is secondary. It is not a guarantee or a validation of your knowledge on Google Cloud. That validation comes from your own skills and experience, and how do you manage the services, how do you manage the operations for Google Cloud services. That's is more important. That's what you need to focus on. So that is what we are going to do here. We will also touch base some of the architectural aspects also in this training. However, this training will not be focusing on any of this. We will touch base some of the services, but we are not primarily focusing on any professional or architect level certification in this training. Is everyone with me on this? Great. Well, I'll put that into the chat window if you want to explore. Uh, all right, so I put that into the chat window. You all can explore this page and you can see specifically what all is asked in the certification with respect to the certification curriculum, cost of the certification, the duration of the certification, number of questions that comes, the length of the certification, the certification guide, which is the exam guide that basically contains the syllabus in terms of what kind of services or questions comes in the certification. So you will see all those. For example, associate cloud engineer comprises of 5 sections, and the weightage of each section is approximately 20%, which means they are divided in equal weightage. And then it is for 2 hours. It comprises 50 to 60 questions. Passing percentage is 70, which is you need to secure 70% to pass the certification. And in fact, you will also have access to the training for this certification. You will also have access to sample questions. So this is where you, on this documentation, you get everything. And if you want to register for it, you can register for this certification by using a Gmail ID, by using a Google account, which is a Gmail ID. So that's about this certification. Similarly, for other certifications, you can see what exactly is being asked in that certification. So you can go through it in your spare time. Let's get back and let's talk about the first thing first. So the first thing that we need to focus on is the fundamentals. So let's get started, which is Google Cloud fundamentals. So this is the first topic that we need to focus on, Google Cloud fundamentals. Now, when it comes to Google Cloud fundamentals, we are not focusing on cloud computing fundamentals. We are focusing on Google Cloud fundamentals here. However, to bring everyone on the same page, I will spend some time and I will use the official presentations from Google Cloud. Since I'm a certified trainer from Google Cloud, I have access to Google Cloud Trainer portal, wherein Google provides official presentations, official documentations, official ebooks, in fact, official dumps for the certifications also. So I will be using all official documentation, no personal, presentation, nothing that I have created for myself. I will also take some references here and there whenever it is needed, because you don't find everything in the official documentation, but majority of the delivery will be using official documentation. So let's get started, because nobody understands more than what Google understands it, or nobody understands Google Cloud more than what Google can, help you with. So let's get started. So we'll get started with Google Cloud fundamentals, core infrastructure. So let's understand the core infrastructures of Google Cloud. Okay, so we will get started with the fundamentals of cloud computing, and then we'll come to Google Cloud. So the first question is, what is cloud computing? Uh, Now there are multiple experts out there who have created their own definitions of cloud computing. There is a definition that you can find from Wikipedia. There is a definition from Google itself. There is a definition from CIS. There is a definition from Gartner. So there are multiple players and they have put their own definitions of cloud computing. Now, what NIST talks about cloud computing, or how does NIST, which is National Institute of Standards and Technology, now in short, we call it NIST. NIST has a very special mention, or NIST has a lot of significance in cybersecurity and cloud security. When you are learning cloud, you will realize that by default you automatically have learned a lot of security. Cloud is all about security, because when you host your workloads and applications in cloud, you need to ensure that you host them by taking into consideration all best practices related to security of that service. So NIST, which is a non-profit org primarily focused in the field of information security, cloud security, cyber security, what they say that cloud computing is a way of using information technology that has these five equally important traits. So that's what they say, that if there is there is a service that contains these five traits, then it qualifies for cloud computing service. So what these traits are: first, customers get computing resources that are on demand and self-service. So any cloud computing service or cloud computing service provider, which is known as cloud service provider, they basically provide you on-demand services. When I say on demand, it basically means that if you need a machine as we speak, you log into the console, you provision a machine. You don't need to register in advance, or you don't need to send a request a couple of hours in advance to cloud service provider that you would need a service in future. It's on demand. As in when you go ahead and provision it. And you will start to pay on usage basis. So if I provision a virtual machine at 33 minutes past 5 in the evening IST, and if I use it for 1 hour, and at sharp 33 minutes past 6 IST, I delete that virtual machine, decommission it, terminate it, I will stop paying for that resource. I will only end up paying for an hour of usage of that resource. That's how it works. So it says on demand and self-service. When I say self-service, it basically means that you can yourself provision, manage, configure these services. You don't need Google intervention or Google Google Cloud service or Google Cloud support at that point in time. Second, customers get access to those resources over the internet from anywhere. That's another trait, another characteristics of cloud computing. A service will only be considered as cloud service when it is accessible from anywhere across the globe over the internet, unless explicitly restricted. For example, if you want to host a website in Google Cloud and you want to make it available to everyone out there, I can say that your service qualifies for cloud computing service because your users are spread across the geographies across the world and they can access your application or access your website. But you yourself can put geographical restriction. Let's say you don't want users from China, users from Russia, or users from any blacklisted location or geography access your website or application, you can put that restriction. So that's optional. That's that's your own way of managing the application security. But by default, when you host a service in cloud, it is accessible to the rest of the world. Third, the provider of those resources allocates them to users out of that pool. So cloud service provider, they have a pool of resources. So for example, Google Cloud has a huge data center that contains thousands of servers, petabytes of storage, multiple networking and security devices. Now, what you do as a customer, you basically rent out some space or some capability or capacity from that pool of resources, and it is granted to you by the service provider. The resources are elastic, which means they are flexible, so customers can be. Resources are elastic, which means I can start with one CPU core and 1 GB of RAM. As in when I need more capacity, I can increase it or I can decrease it on the fly. I can in fact use auto scaling, which means I don't need to manually scale it up and scale it down based on certain configuration, certain logic, or certain threshold. Google will do it automatically for you. That's what the next feature is. And the last feature is customers pay only for what they use or reserve as they go. That's the another feature of cloud computing, that it allows you to pay for resources for the time that you are using them for. It's pay as you go. And you can also do reservation. For example, if you provision a virtual machine today and you deploy a production website on it, a production application on it, it basically means that it will be running 24 across 7. It will be running throughout the year. So 24 into 7 into 365. So Google gives you an option to basically purchase reservation. Reservation means you commit to Google that I will be using this service for next 1 year, 2 year, 3 year, and Google in return will give you additional discounts over and above the pay as you go price. So if the cost of the service is $100 a month, and if you take reservation, if you purchase reservation, you may get up to 70% discount, depending on what that service is and for what duration you're purchasing the reservation for, up to 70% discount, which in other words would mean that you will end up paying $30 for the same service post purchasing reservation as compared to $100 when you were using that service in pay as you go model. So these are the 5 characteristics of a cloud computing service, and whosoever is providing cloud computing services, they are ensuring that the services adheres or services encompasses these capabilities. That's what cloud computing is all about, or that's how you define cloud computing, that it's a method of providing on demand, pay as you go, self services, flexible, elastic services to end users from anywhere in the world on any device from internet. So internet is the medium. If you don't have internet, if you don't have connectivity, you will not be able to access or consume cloud computing services. Any question on this? Any question, guys, on this? Okay, let's look at the history. Guys, I need acknowledgement. Otherwise, I will not know whether you are listening to me or not. Because while I'm talking, while I'm presenting the screen, I actually don't see any one of you because you're not turning your cameras on. Okay. And I'm not forcing you to do that because I respect your privacy. Uh, then comes the history of cloud computing. Now, when I say the history of cloud computing, you need to understand that when it got started. So history is very important. If you remember, yesterday I told you that you may have good knowledge of various clouds, but if your basics, if your foundation is not strong, you will not lead anywhere. It will not take you places. You will be limited in your roles and responsibilities. That is why basics are very important. So we have seen cloud computing overview, characteristics. Next is history, cloud computing history. Now, when it comes to history, uh, if you remember in your probably during your 10 plus 2 or during your college, you must have studied about generations of computers. First generation, second generation, third generation, fourth generation of computers. And during that time, you must have, if you remember, there were, I'm saying back in 90s, 80s, 90s, 85, when they introduced computing, they created the very first computer, and that computer used to be very huge in size. It would, I would say, the entire room would accommodate one computer, and it would require a lot of cooling capability. The storage capability of that computing system was not that huge as you compare it today. That's how the computing started. So we started with first generation, second generation, third generation, fourth generation, and with the dot-com revolution, when internet became accessible to almost everyone, when it was not a griffin goods, when it was not a premium service or a luxury service, when it became a common man service, a common business service, that is where the dot-com revolution started. And most of the businesses, they started using technology to deliver or to enhance their business operations. That's where they started. However, there was a challenge. The challenge at that time during the cloud computing history, the challenge that they had was hardware resource utilization. So low hardware resource utilization. What would basically happen? You would purchase a server that comes with a set hardware, probably a couple of CPU cores and some gigabytes of memory, then probably a couple of GBs or MBs of storage, ROM storage, which is read-only memory. The utilization of that hardware was very low because you can only deploy one application on that hardware. If you want to deploy multiple, you need to purchase multiple hardwares. So that was the challenge, that low hardware utilization was there. And this challenge basically created an opportunity, and that opportunity was seen by VMware, and VMware introduced a new technology with the name virtualization. So virtualization was introduced. Now, what was virtualization? Virtualization was a technology that allowed you to maximize the hardware utilization. With the virtualization in place, you could break a hardware into multiple virtual machines, logically into multiple virtual machines, and you can run an application on each virtual machine. And each virtual machine running on that hardware thinks as if it is the only virtual machine running on that hardware. And you can have different operating systems on those virtual machines. So that was virtualization. Now, virtualization is known not only for server, you can also virtualize network, you can also virtualize storage, you can also virtualize applications. So you can do all of this virtualization. So you can do network, storage, server, and application virtualization. Now, networking and virtualization made way for cloud computing. So after that, cloud computing came into existence. So first it was all hardware everywhere. Then virtualization was introduced, and virtualization introduced cloud computing. Cloud data centers or cloud service providers, what they are doing in the backend, they are just creating huge data centers which comprises of hardware, and then they are using virtualization technology to virtualize that hardware and offer these services to end users. That is why all the services in cloud are virtual. So you have virtual network, virtual storage, virtual machine, everything is virtual, virtual databases, everything is virtual in cloud. So that's what virtualization made way for cloud computing, right? Now, when cloud computing got started, now understand one thing. When I say virtualization and networking, remember the statement: networking and virtualization are the backbone of cloud computing. Remember the statement, guys. Networking and virtualization are the backbone of cloud computing. So if you really want to excel in cloud domain, if you really want to learn and then be an architect in cloud, or you want to become a multi-cloud architect, you must have sound understanding of networking and virtualization. Then only you will be able to design and architect landing zone or cloud infrastructure for applications that needs to get migrated from on premises or from other clouds, or applications that needs to be built from scratch in the cloud, which is greenfield deployment. So whether it is brownfield or greenfield, whether it is migration from on premises, whether it is migration from other cloud service providers to Google and vice versa, networking and virtualization concepts are very critical. So you should have good understanding of these concepts. Now, what I'm trying to say here is that if you don't have good knowledge of networking and virtualization, this is an opportunity for you. We have an upcoming weekend. Please spare a couple of hours over the weekend reading about networking and virtualization. I'll share the resources with you. I'll share a couple of networking and virtualization resources, presentations from my previous training that will help you to learn the nitty-gritty of networking and virtualizations. And if you already know, then it will help you to bridge the gap that you have in your knowledge with respect to networking and virtualization, because it is very important. So this part is very important. So let's go back to the presentation. So let's see the history of cloud computing. So it all started with colocation. Colocation basically means that businesses were renting out servers at data centers. Now, not all businesses had budget or funds available to build their own data center. What they were doing instead, they were renting out space or hardware in somebody else's data center. That topology or concept is known as colocation. Cloud is nothing but colocation. Then second wave, which is virtualized data center. Now, since you were using colocation, you were hosting your hardware in those data center. Either you purchase it and then host it, or you let the service provider, data center service provider, to also have the hardware made available to you. Then came the second wave, which is virtualized data center. Virtualized data center basically means that now that uh, you have been aware of VMware, you've been aware of Citrix virtualization, you've been aware of Microsoft Hyper-V when you manage these data centers, virtualized data centers or colocation, what are the challenges? The challenges are that it's user controlled environment, user configured environment, which basically means that you are controlling it end to end. You are managing it end to end. So you are responsible for the availability, performance, fault tolerance, disaster recovery, operational excellence, and all those capabilities. However, Then came the third wave. Third wave was container-based architecture. Container-based architecture basically means that before cloud computing, people understood that some applications doesn't need extensive server environment or extensive resources. They can be made to run inside smaller, or they can be made to run with small set of hardware that is known as containers. So containers based architecture also started. I'm saying it is still equally popular today, and we'll talk about it. Then comes the third wave, which is cloud is available to Google customers. Now, in the third wave, Google came into the picture. Since this is Google-based presentation, so they will not specifically talk about whether there were other businesses or other players existing before Google Cloud. I will talk about that part. So even before Google came into this business, Google officially came into cloud computing business in 2014. Starting from 2012, they started offering application services, or they started offering platform as a service, PaaS services, which is App Engine. But they started with Compute Engine that became the first cloud computing service from Google Cloud. They introduced that in 2014. So they officially jumped into cloud computing business in 2014. Prior to this, Microsoft Azure was there. And prior to that, Amazon Web Services was there. Amazon Web Services came into cloud computing business in 2006. In 2006, they officially launched Amazon Web Services or AWS Cloud. And by the time Google introduced this service, AWS was already a leader, sitting at number one position, which is still the case today. As we speak today, AWS continues to be a leader in cloud computing. Microsoft Azure comes at second place, and Google Cloud Platform maintains the third position. As per Gartner's Magic Quadrant, which is a trusted source of information across the industry or across the technology industry. So AWS maintains number one position, and most percentage of cloud revenue goes to AWS as we speak today, which doesn't mean that Google is not a good cloud service provider. Yes, Google has edge when it comes to Kubernetes. Kubernetes was a service that Google itself developed, and then Google made it open source. Later on, they repented. I'm saying they really cursed themselves of the decision to making Kubernetes open source, because by the time Google realized it, a couple of additional businesses created their own version of it, and they made a lot of money from it. It is similar to Linux. Somebody made it open source, and then companies like Red Hat, SUSE, Ubuntu, CentOS, IBM, Amazon, they all made money from that open source Linux by creating their own flavors, customized a version of that operating system. So same happened with Google also. They introduced Kubernetes for container orchestration and management. They made it open source because at that point in time, I'm saying not even 10% of the businesses were using containers. So they just thought that, okay, let's give it back to the community. Let's make it open source. Later on, they realized that they did a great mistake. Today, Google provides Google Kubernetes Engine service. AWS provides Elastic Kubernetes services. Azure provides Azure Kubernetes Engine services. When you compare the capability, they all fall in the same category. They provide the same capabilities. However, Google Kubernetes Engine is much more refined and advanced and cost effective as compared to AWS and Azure, because it is their proprietary technology. So this is how they got started. So in 2014, they officially started, and since then they have added a lot of services to their portfolio. As we speak today, Google has more than 200 plus services that it is offering from its cloud platform, Google Cloud Platform. Now, when it comes to service offerings, we primarily divide them into three categories: infrastructure as a service and platform as a service. And then in the end, you have software as a service. So what is these categories? When it comes to infrastructure as a service, I stands for a service wherein you deploy the service in cloud service providers infrastructure, and you manage the service, and you also manage the underlying infrastructure around that service. That's what IaaS is. The example of IaaS is compute engine or virtual machine service. Because you deploy a virtual machine, then you are responsible for managing the availability, performance, and security of that virtual machine. That's IaaS. Then comes PaaS. PaaS basically means you deploy the service and the underlying infrastructure will be managed by the service provider, which is Google Cloud in this case. That's what PaaS is all about. Now, if Google is managing the underlying infrastructure, if Google is responsible for availability, performance, security, definitely Google will expect you to pay more for PaaS services, and hence PaaS services are expensive as compared to IaaS. Then, when it comes to payment models, in IaaS, you pay for what they allocate. It basically means that if you create a virtual machine, you pick and choose the CPU, number of CPU cores, the amount of memory and storage for your virtual machine. If you need additional services like public IPs, you pick and choose. So basis on what you pick and choose, and they allocate as you request for it, they charge you accordingly. When it comes to PaaS, you pay for what they use. So you will pay for what they use basically means that if you are provisioning a PaaS service and in the backend, as part of that service, they have allocated certain infrastructure components to you, then basis on that usage, you will be paid for it. So that's the payment model. Now, when it comes to evaluation of cloud computing, now I'll switch to my personal presentation, and there you will get a clear distinction between these three types of services from the migration perspective also. Okay, so let's look at this this presentation. Is that visible to everyone?
It's Ravi.
Yes.
Okay, great. Let's understand it. So in this presentation, I will explain the fundamental difference between IaaS, PaaS, and SaaS by taking a use case. So my use case is that I am your consultant, you are my customer. Now you approach to me and say, Raghuveer, we want to migrate to Google Cloud. However, we are not sure what services in Google Cloud we should be using. We are not sure what level of control we will continue to maintain in Google Cloud. We are not sure whether the security of my workload and application will be similar in Google Cloud, or it will be enhanced, or there will be certain limitations. So I'm not sure about a couple of things. Can you help me explain? Now, when I get this problem statement from you, I'll ask you a couple of questions. So I'll ask you questions in terms of, okay, help me understand how your infrastructure or application looks like. How many servers do you have? Are they virtualized? If yes, then what virtualization technology do you use? What kind of operating systems are you using? Are you using Mac? Are you using Windows? Are you using Linux? If you're using, then whether it's client and server operating system. What kind of applications are you using? Do you have purchased some applications like Oracle? What databases are you using? What programming platform do you use? Are your applications three-tier applications, two-tier applications, monolithic applications, or microservices-based applications? I will be asking you a lot of questions. After I'm done with those questions, then I will suggest you these service delivery models. So I say that now that I have collected all the information, let us understand how cloud functions. In cloud, there are three delivery models. There are many, but there are three universal delivery models, and let's compare them with on-premises. So when it comes to on-premises, and if we try to break a data center where you host your workload and application into a technology skeleton. These are the services that you typically use. So your data center, I would say when you build a data center, it basically starts with networking. When I say networking, the first thing that you do while building a data center is to lay out cabling. You lay out cables and you create a network so that you can deploy hardware and you can connect that hardware to those cables to provide connectivity capabilities. So you have networking, you have storage, which is storage hardware, you have servers, which is CPU and memory, and then you also purchase some virtualization solution. So let's say you go with VMware. Now, with the help of VMware, you will virtualize server, storage, and network. And as part of that virtualization, you will end up creating virtual machines. Those virtual machines that you create, they will be running operating systems. Now you can create multiple virtual machines. Those virtual machines can be running Windows Server OS or Linux OS, depending on what OS you want to host your application on. Now, that virtual machine contains a middleware. Middleware basically means any application that you deploy. So people who are into middleware team, they basically deal with Google Chrome, they deal with Adobe Acrobat Reader, they deal with browsers, they deal with third-party applications. That's what middleware is. Your virtual machine also has a runtime. Runtime basically means either your machine is running or it is in stop mode or you are currently restarting the machine. Your machine has some data stored on it. Data stored on it in the form of disk. So your machine contains disk or volume. In the language of AWS, we call it volume. In the language of Azure and GCP, we call it disk. So your machine has disk attached to it. And your machine is also hosting an application. So an application is hosted on the machine. That application is using these disks to store data. Either your machine is up and running or stopped down. Your machine is using some additional applications. That's how a traditional on-premises infrastructure looks like. That's what you have in a traditional data center. Now you are moving this portion into Google Cloud. This is your portion that you're moving into the cloud. You cannot move this portion into the cloud because this is your hardware. So what is my first delivery model? My first delivery model is infrastructure as a service. In this model, all of this hardware, this virtualization, server, storage, and networking, all of this you leave on premise and you migrate this layer, which is OS, middleware, runtime, data, and application into cloud. And the moment you migrate that into the cloud, you continue to manage it. So here in the on-premises, you were managing everything, which means the hardware as well as your machine, your operating system, application, data. But when you move to cloud, the first service model that you get is infrastructure as a service. In that model, you get to manage your machine and everything above it. And the hardware is managed by the vendor, which is the service provider here, which is Microsoft Azure, Amazon, IBM, and Google Cloud, Alibaba, Oracle, and other cloud service provider. That's infrastructure as a service. However, this has a challenge. The challenge is what if your pain point or what if your motivation to move to the cloud was to get rid of infrastructure overhead? You don't want to manage the IT. You want it to be managed by cloud service provider. You only want to focus on your application and data. In that case, there is another method, which is platform as a service. So if you don't want to manage the infrastructure, when I say manage the infrastructure, this portion, you don't want to manage the operating system patching, security, you don't want to manage deploy an EDR solution like CrowdStrike or Microsoft Defender for endpoint, you don't want to manage security, data leak. If you don't want to manage it, then you have another service delivery model, which is platform as a service. In this model, the cloud service provider, which is Azure, AWS, GCP, they will manage the infrastructure as well. Other than managing the hardware, which they already manage in all the cases, they will also manage your infrastructure. So you can directly host an application by choosing the backend infrastructure on which it needs to run. Google will manage that infrastructure, the availability, performance, security, and you will only focus on your application and data. That is your responsibility. That Google cannot manage on your behalf because Google doesn't have access to this layer, or Google doesn't understand your application and data. So you manage it. And definitely, since you are letting somebody else to manage it, or you want somebody else to take your pain, you need to pay for it. So PaaS is expensive. Now then comes the third layer. The third layer is, what if you were using some custom applications to manage your customer communications, or to manage the IT service management, which is incident, problem, and change management? Then you have third option, which is software as a service. In this model, the cloud service provider or the vendor, it manages everything, including the application and data it manages. For example, Office 365. When you want to use Office 365, which is now known as Microsoft 365, you don't create or build anything. All you do is subscribe. You navigate to portal.office.com, you subscribe, you select the plan, you get access to the admin portal. There you create your identities, and you can grant them mailboxes, assign quotas, assign policies, and then you are good to go. Your employees can manage the M365 services or consume it. So Microsoft Dynamics 365, which is the CRM solution, SAP Success Factor, which is the entire collection of multiple capabilities, and Salesforce Cloud. That's software as a service. So anything that is readily available that does not require you to build the infrastructure falls in software as a service category, and you can consume it readily. You can start using it from next moment onwards after you're done with the subscription. So these are the three options that we have in cloud. Now, when it comes to migration, when I used to actively participate into migration projects when I was working as a consultant back, starting from 2011 to 2016, during that time frame, I did migrate a couple of applications and workloads into multiple clouds for multiple organizations across industry verticals, across FMCG, BFSI, oil and gas, aviation, multiple industry verticals. At that point in time, what I would personally do, when I do the migration project, before migration, there is an assessment phase. So you first do the assessment and then you do the migration. During the assessment, I will identify what percentage of that infrastructure from client end, including the application, can be migrated to cloud. And after I have that data, the first thing that I will see is, out of this, how much can be migrated to SaaS. So my approach used to be SaaS followed by PaaS, and then in the end IaaS. Why? Because I wanted my customer to leverage the benefits of cloud computing or benefits of cloud. If you end up managing the infrastructure in cloud as you would do at on premises, what difference it brings to your life? Then you're not using cloud. You're just hosting your services in someone else's data center. Cloud is all about innovation. Cloud is all about using cloud native technologies. Cloud is all about modernization. Cloud is all about AI ML, artificial intelligence, machine learning, automation. And that is only possible when we use SaaS or PaaS. In infrastructure, you have very limited aspects. So that's what I would do. Now, this approach keeps changing. You cannot put everything into SaaS or PaaS. Sometimes a customer would want to retain control on certain applications because they are mission critical for the customer, or those applications needs to adhere to certain regulatory standards and compliances. And as part of that adherence, they need to manage it all end to end. They can't afford or let the cloud service provider to manage it on their behalf. So it's a choice which is governed by multiple factors, and you just need to understand those factors, put them into a meaningful order, and accordingly identify that what goes into IaaS, what goes into PaaS, and what goes into SaaS. That is very important. Why? Because you will be managing the infrastructure for your customers. And it is not that you will start to manage once they are 100% into the cloud. You will start to manage the project as and when they are migrating to cloud. So you will become part of that migration journey, and it becomes very important for you to provide right suggestion or right consulting to your clients, so that if you ever feel that a specific service is more suitable towards PaaS versus IaaS, you can share that information with your client. So that's about IaaS, PaaS, and SaaS. And if you look at the arrow on the top, you will realize that in traditional on-premises, you have more control. And when you are moving from on-premises to cloud, from one service model to another service model, you're losing that control. So in IaaS, you have more control. In PaaS, you have less control. And in software as a service, you have least control. That's what you need to understand here. Is everyone with me on this? Any questions on that presentation? Now let's understand the, so we are done with the fundamentals. That is all that I wanted to cover in the fundamentals. So you understand cloud computing. You have understood cloud computing service delivery models, which is IaaS versus PaaS versus SaaS. Now, as I said that there are three universal models. The managed service providers like yours, employer, and others, Wipro, HCL, Capgemini, Cognizant, Accenture, HCL, what they TCS, what they have done, they have created their own version of service delivery model. So some provides DB as a service, database as a service, or security as a service, which is your SecOps, SecOps team. That's exactly what you do. You provide security services, right? Some provides machine learning as a service, MLS. So what they have done, they have curated their own version of service delivery models. Some provides disaster recovery as a service, like DR as a service. There are multiple, but they are just internal. They are not universal. The universal are ISPAS and SES, which is universal, which everyone understands out there. Rest are local to a company. So this is what you needed to understand: service delivery models in cloud computing and different types of cloud, which is public, private, hybrid, and community cloud. So you also need to understand this. Can somebody explain the difference between hybrid and community cloud? Help me understand the difference between hybrid and community cloud.
Hybrid cloud is combination of both public and private cloud.
Okay.
In the community cloud, it is like it is between our organization only, not outside. Like IBM with community cloud.
Okay. Any other participant? Any other participant who can explain the difference between hybrid and community? Okay, let's make it easier. Let's explain the difference between public and private cloud. Who can explain the difference between public and private cloud?
Like in public cloud, like we are getting like it is responsible by CSP, like cloud service provider. We are like taking some amount of storage and like
Hmm?
it is the responsibility of a cloud service provider, and the cloud service provider will manage all the infrastructure. But in private cloud, uh, like we need to manage our whole infrastructure.
Okay. All right, so guys, I will share a presentation with you. I don't have time to cover the fundamentals. I'm saying to get into the details of fundamentals, but I'll share a presentation that has clear differentiation between all these four cloud types. However, for your knowledge, as the name suggests, public cloud, it is available for everyone. So anyone, any business or an individual can use services from public cloud. AWS, GCP, Azure, Alibaba, Oracle, IBM is an example of public cloud. You don't need much technical knowledge to use public cloud. But when it comes to private, as the name suggests, it is not meant for everyone out there. This is meant for a specific organization. So your employer can take advantage of solutions using which it can build a private cloud infrastructure. Now, when you build a private cloud, it is only available to yourself and your colleagues. It is available to employees of the same organization. However, you can expand the access to outsiders, vendors, partners, contractors also. And since it is private cloud, you're responsible to manage the entire infrastructure, application, and cloud also. So it is an expensive affair. That's private is. Hybrid is a combination of public and private cloud. It's not a cloud. It is just an arrangement that will connect or that will let you consume resources from both public and private cloud. That's what hybrid is all about. And hybrid is nothing but networking. You must be sound in networking concepts, then only you can build a hybrid cloud, which basically means you will configure connectivity from your private cloud to public and vice versa, so that your employees, your users can leverage, can consume resources from both of them at the same time. That's what hybrid is. Now, what is community? Community basically means that there are many companies who have similar requirements with respect to security, governance, compliances, availability, performance, and they are part of the same industry vertical. For example, bank. Now, all of the bank that operates in India, they all are governed by RBI, Reserve Bank of India, and RBI rules are same for all the nationalized banks. From the security perspective, from the availability perspective, RBI doesn't only mandate the security, it also mandates availability. RBI clearly says that the banking services must be available 24 across 7. It's a mandate. The services must be secure. It's a mandate. The services must be available to end user via different methods, which is mobile app, internet banking, kiosk, ATM, physical branches. That's a mandate of RBI. So all the banks needs to follow it. Now, all of these banks can collectively build a cloud and they can host their services in that cloud because the requirements are same from legal perspective, from technical perspective, from regulatory and compliance perspective. So if they build a cloud that they will only use to host workload and application, that will become a community cloud. Now they can either build it by themselves if they have capabilities, skills, or they can ask a third party like Tata Communications Limited, Airtel, Reliance Jio, Cloud4C, Sifi Technologies. These are the companies, and Azure, AWS, and GCP also. These are the players or businesses who knows how to build a community cloud. So they can build a cloud for these banks, wherein these banks will only host their workloads and applications. You can consider is equivalent to private cloud, but it is not completely private cloud because banks are not managing it. Somebody else is managing it. That's community cloud. The example is Salesforce Cloud, the government community cloud. The government of India and the government of multiple countries have got a dedicated region created by Azure, AWS, and GCP, wherein they will only host workloads and applications. No other customer or individual is allowed to do that. That's what community cloud is. So I'll share the presentation. It has multiple slides for each cloud, which differentiates each cloud from other from the features, limitations, and use cases perspective. Go through it. That will clear your doubts and that will build a sound foundation, when you say that you have been working into cloud. Okay, let's talk about the global infrastructure of Google Cloud. So, as I said, Google is at third place. That doesn't mean that Google is not a great cloud service provider or Google is a mediocre. No, Google has its own place. Google has its own set of customers, and Google is heavily invested into developing, enhancing its cloud service portfolio. Google has invested or Google has committed to invest approximately $20 billion in next 5 years, which means $4 billion per year. Imagine the how significant this investment is, and with this investment in place, how Google is going to enhance and introduce new services. So that's what Google is doing, and that is why most of the customers who are currently using AWS and Azure, they are getting motivated to also try Google Cloud services. And hence, you get customers coming to you, hosting their workloads and applications in Google Cloud, now requesting you or expecting you to support those workloads and applications. To begin with, you will be part of support team, but later on, when you showcase your skills and capabilities, you will get larger responsibilities of design and architecting the solution also. So this is what the journey will look like. So let's understand Google Cloud global infrastructure. So it says Google has largest network of its kind. Google's investment in its network runs into billions of dollars, which is true. Uh, as I said, I have been working with all the three clouds for a long time, and these days I'm supporting large enterprises who wants to build a hybrid network. So when it comes to Google Cloud Network or Google Cloud VPC, it is much mature and you will find it at a higher side. It's the largest network that you will find. Now, when we talk about the network, you will see that how it is different from Azure and AWS. So, when it comes to the Google Cloud networking, Google is, I'd say Microsoft Azure, AWS, Google is much older than these companies. And Google has been into search engine business. That is why Google has built its own network across multiple geographies to provide high performance and end user experience. So Google network is connected in the backend. And if you look at this image, you will find this is the world map. And here you will see that Google network is everywhere. Google is well positioned in US. Google is in Europe. Google is in Asia Pacific. It is in Australia and New Zealand. It is in South Africa, South America. Google network is everywhere. It is well connected. Google has in fact laid down its own undersea water cables, undersea water optical fiber cables. The entire internet, the backbone of internet is optical fiber network. Without optical fiber network, internet cannot function. Internet is not Wi-Fi. Wi-Fi is just not even 1% of it. It's the wired network. So it's the optical fiber cables which are spread across hilly terrains undersea, which is connecting the entire world. And Google has its own optical fiber network. That's what Google is all about.